Okay, chapter 4.2, real vector space. Now, this question is very common. Every semester for sure, one question for you to prove. Okay, so this is the definition for the vector space. Okay, you can see already state here, a vector space is a set where all the elements consist of vectors and the operation defined involve addition and scalar multiplication. Now, vector space is an ordinary, arbitrary, non-empty set of objects. Okay, so again, this is all the properties involved. Okay, A1 until A10. Okay, you can read it by yourself. Okay, so without wasting any time, so let us look into one by one. Okay, look at the example 1. Okay, so I already purposely highlight here. Okay, this one shows is addition, this one shows that multiplication or scalar multiplication. Okay, so you look at how you're supposed to solve. Okay, so actually if you want to prove, right, you need to prove all the axiom involved. Okay, so this is all the things. So you may, example 1, I leave it for you to read by yourself. Is it okay? Okay, so let us look into example 2. Now example 2 here. Okay, so because, okay, now just before I forget, to prove vector space, okay, you will need to fulfill all the axioms involved. Okay, A1 until A10. Okay, but to show not a vector space, you only need to have one of the axiom to be rejected, okay, or not satisfied or not fulfilled. Then it can say that that is not the vector space involved. Are you clear with this? I repeat myself again. To show that it's a vector space, you need to prove from the axiom A1 until A10. But to show that the vector is not the vector space or not satisfied, you only need to have one axiom to show that is not satisfied, then your vector space will not fulfill. You get what I mean? Okay, so example 1 is to show how you're supposed to prove it, because the question said show that V is a vector space. So if that's the case, you need to find every and prove every single axiom from A1 until A10. But no worries, this kind of question will not come out. If come out, I think one question will involve more than 10 marks. Okay, example 1 here is just to show you how actually the things been done. Okay, so you must prove every axiom is satisfied, then that is the vector space involved. If one of the axiom is not satisfied or not fulfilled, so the vector space will not be the particular vector space involved. Okay, clear? Okay, let us look into the actual questions like example 2. Okay, so example 2, you see, let V is a set of vector in R square, okay, with the operation defined as follow. Okay, so you are given two information here. Okay, one with addition, one with scalar multiplication. Okay, so how does it say? So it means that this is the answer for the addition, and this is the answer for scalar multiplication. So you may need to determine whether the axiom is satisfied or not. If not satisfied, so means the V is not the vectors in R square or the real vector space dimension 2. Is it okay? So how to write it, how to prove it? Okay, for this topic, there have no calculations involved. You only play with the axiom. Okay, so how does the things come in? Okay, very simple. Okay, so first you need to let what? Okay, you need to let the vector involved. Okay, you have a few ways of doing it. Okay, I show you one first. Okay, so how actually you read this one, class? This is example 2. Okay, how actually you read this one? Okay, now you always assume in this way, class. Okay, the A here shows is the first element, This is the second element for the first vector. C is the first element, D is the second element for second vector. You get what I mean? That? So this is how it goes. Okay, so how you read this? So it means that you have 2 times with the first element in vector 1 plus first element in vector 2. Okay, so after that the second element is second element in vector 1 minus with second element in vector 2. Okay, same goes with this one. So if you have a k AB, so you have 3 times with the first element and k times with the second element. Okay, this is how you read. Okay, so how it's supposed to start? Okay, I already show you clearly in your notes in the mind map. You see, in my mind map, I already show you one by one. You see, first step, what you're supposed to do, or you need to have all the representative. Okay, if that is r square, then you need to have in r square, means identity in real vector space dimension 2. If that is about polynomial linear, P1 means linear, so you need to have linear. If let's say P2 means quadratic, you need to have in quadratic. Okay, so why I put or? Because sometimes you follow the pattern of the questions given. If you start with x squared, so you will have in start with x squared. If the question start with constant first, you will start with constant. Okay, same thing with P1. You see, if the pattern of the linear is start with x first, so you start with x. If let's say the pattern start with constant first, you will start with constant first. Okay, and do remember the step 1 here is how you assume or let. Okay, so whatever variables that you put here don't overlap. We need to set that. Let's say px is ax equal ax plus b. Your qx, you don't put ax plus b anymore. Okay, you use other alphabet. Is that okay? Okay, so I found out that students are easier to cope up with A, B, C, D, E, F, G like that. Okay, with alphabetical. If not, you want to have U with U1, U2, V with V1, V2 can be done also. It's all up to you. You must remember, just one concern is all the informations that you have or all the elements that you have will not repeat or overlap. Okay, so after that, step 2 is what? Okay, so if you need to fulfill all the things, okay, with the given axiom from the question, after that, step 3, please remember, this is another things that students like to skip. Okay, you need to fulfill, if your left hand side equal to right hand side, please answer back the question, is the axiom holds or satisfied? Okay, if not the same, so means that the axiom fails or not satisfied. Follow and answer back the question stated. Is that okay? Okay, let us back to our example 2 again. Okay, so as I mentioned in the mind map, okay, step 1, what you need to do, you need to let U and V. Okay, U1, you can have U1, U2 element of R. Okay, or you want me to share with you A and B. Okay, can be done also. Okay, as what I have stated in the mind map, right? Okay, so no worries, you can do it again. Okay, so let U, so you have A, B. Okay, V, you will have CD. Okay, and don't forget to highlight is the element of R square. Element of R square. Why? Highlight in the question R square. Is it okay? Okay, so let us continue. Okay, so what is your step 2? What is your step 2? Okay, because question want you to test whether this axiom satisfied or not, right? Okay, so you just copy. So from here, what is your left hand side? Just write. Okay, so K U plus V, right? So K What is your u? Just substitute in first. Okay, so you have what? What is your u? AB. What is your v? CD. Is it okay? Then close bracket. Okay, so what will you do next? Okay, what you should do next, you look at the pattern. Okay, so what's the pattern now? Okay, so look at this one. You have a vector plus with a vector. So means which one? Vector plus with vector. So the first one, because you have a vector plus with a vector. Is that okay? So it's the first one. So what's your answer then? Is 2a plus c, b minus d, right? Okay, so since that you are in the form of a, b, c, d, so you just follow. Okay, as I mentioned, a represent the first element, c represent the third element, b represent the second element, d represent the fourth element. Is that okay? Okay, this is very logic part. Okay, so what you need to do, just write back. Okay, so means that you will have 2a plus c, b minus d. Is that okay? Okay, so look back again, this part. You have a constant k with dimension 2 vector. You have constant k scalar with dimension 2 vector. So it's the second condition, right? It's okay? So if that is the case, right, I always like you to highlight, okay? Highlight what? Highlight, this is your latest A. This is your latest B. Is it okay? Because you want to guide back to your condition. Is it okay? Okay, I'll go very slow. Okay, no worries. Okay, so what do you have? So K, no more K, sorry. Okay, so what is your answer? You will have, what do you have? You will have 3, right? Okay, you have a vector already. Okay, so you have 3. What is your A? Is it 3A 吗? What's your latest A? 2A plus C. 现在 Okay, so you will have 2A plus C. Is it okay? So second element is what? Is KB. 现在 So what do you have? You have K. So what is your latest B? Is this one, right? This one. Okay, so you have B minus D. Okay, you want to expand or you don't want to expand, it's all up to you, but you must ensure that later both the answer must be the same. Okay, so if you want to expand, you just expand plus 3c. This is KB minus KD. Okay, so anything else? No, so you need to proceed with the second one. Okay, so your right hand side. What is your right hand side? Nothing to proceed, right? So you just go for right hand side. KU plus KV. Okay, so K, what is your U? Plus K, what is your V? Okay, just substitute your U is what? AB. Your V is CD. Is it okay? Okay, so back to our case again. Okay, KAB. See now, any KAB? Yes. The second condition. Is it okay? Okay, so KAB is what? 3A KB. This one's simple, right? Because it's exactly the same, right? Okay, A is your latest A also, right? So it's 3A and KB. This one very logic, right? Okay, so again, this one is your latest A, this is your latest B, right? So what will be your answer? What's your answer? It will be 3C and KD. Is it okay? Why? Because now your latest A is C. So your latest A is C. Now your latest B is D. So you just replace with D. Okay? So again, look at this. What is this? You have a vector plus with a vector. So which condition that you will refer to? The first one, right? The first one, because you have a vector plus vector. Because you got only two conditions here. Okay? And this is the answer. Is that okay? So let us proceed. Okay, let us proceed. So how? So same thing, just highlight. This is your latest A, this is your latest B. This is your latest C, this is your latest D. Okay? So, what's your answer? 2A plus C, right? So 2, what is your latest A? Your latest A is 3A. 2A plus C. What is your latest C? 3C. Is it okay? So after that, what you have? B minus D. Okay? So what is your B? Your latest B? KB. Your latest D? KD. Okay? So try to write it back. 6A plus 3C. KB minus KD. Okay? So look at these two. Is it the same? You check. Okay? 6A plus 3B. 6A plus 3B. KB minus KD. KB minus KD. Oh, is the same. So what's supposed to do? Yes, you can make a conclusion already. Since your left hand side equal to right hand side, okay, meaning to set your KU, KU, oh, KU plus V, okay. KU plus V equal to KU plus KV, okay. So okay, so later you just write, so the axiom satisfied. So that's the answer. Okay, so if not, you can also have U1, U2 as I show you here. Okay, it can be done also. Okay, but I still prefer you to have A, B, C, D. Is that okay? Okay, thank you.